Good afternoon, YouTube. Here's another JavaScript tutorial by Devil Dog for Life, and today I'm beginning a series on JavaScript functions. Today I'll be covering JavaScript declarations and how to invoke or call a function. So you see here I have my basic HTML page, titles functions, a little bit of CSS just for over here on the side to have it print to the screen where you can see it. And then we'll scroll down here, and under this function declarations comment is where I'm going to build my first function. Before I get started, what I'd like to say is that functions are the purpose of functions are to be reusable. So you, instead of rewriting the same thing over and over and over again, you can create a function and just call that function and pass in whatever parameters or whatever needs instead of rewriting all that code over and over again. So it's reusable. So we'll create a basic function and we'll call it multiply. And then we'll put our parentheses, and then our open bracket and closing bracket, and then in between the parentheses are any parameters that you're going to pass in. If you have parameters, functions don't have to have parameters. And what those parameters are is when you call the function down here, multiply, for it to execute, those parameters then become your what you pass in here. So if you pass in numbers, it will multiply 4 and 6. So with that being said, we'll go back and we'll close this and we'll create a function with no parameters first, and we'll just say return 10 times 2 and close it off with a semicolon so it knows that JavaScript, when it reads this, it knows that this is the end of the statement. And then when you call it, since there's no parameters, you call it without parameters here, file, save, and we'll refresh the screen. And as you see, it prints out 20 over here. So it multiplied 10 and 20. Now say we have a function that we want to be able to reuse, and we don't want to have to rewrite this function over and over again with different names or whatnot to multiply different numbers. We can pass some parameters. So first parameter, we'll just call it A. Second parameter, we'll call B. And then for arguments, we'll pass in 20 and 2, so we'll multiply 20 times 2. And right here, we'll say return A, our parameter name, times B. And we'll save it and refresh the page. And you see it's now 40. So when we go back, so now these parameters become local variables in here. And the values are whatever we pass in here as arguments. So when you're creating a function or a function declaration, the parameters are arguments when you call the function. So if we change this to 4, it'll multiply 4 times 2 and result in 8. So you see it prints out 8 over here to the screen. And let me just cover what I'm talking about real quick. How it's printed to screen. I have a paragraph element here, which is a variable called para_l, and it's equaling a built-in method of JavaScript called document.getElementById. Document would be the object. It's using dot notation to call this method that's built into JavaScript or built into the browser or the window. It's more than likely built into the window object. And then I'm grabbing this paragraph by ID. So P1 is my ID, as you can see right up here in my paragraph element in the HTML. I have a paragraph here with the ID of P1. So I'm grabbing it and storing it in this paragraph L to reference it. And then I'm using down here, when I call this variable, para_l, dot notation, appending a property of JavaScript called text content so that it will print to the screen over here. And it's equal to what I want it to print, which is me calling my function and then passing in my arguments. Alright, well, we're talking about reusability. So let's get rid of this real quick. What I mean by reusability is, like, if I have a var, it could be whatever. I could have var num1 equals 3. And then another var num2 equals 4. And then another var z equals, we'll just say result equals num1 plus num2. And then to print it to the screen, we can just take this invocation out, and we'll just return the variable result. Does a calculation. File, save, and it should print 7 to the screen. And there you go, you got 7. So if I wanted to keep adding different numbers, I'd have to keep writing this out every time. Well, I'd have to come down and do a whole new set. So it's easier just to say function, add, or whatever it's doing. Usually your function names should be something along the lines of what it actually does. And return a plus b. And we'll call it or invoke the function here, add, pass in 2 numbers as the arguments of the 2 parameters. So I'll say 10 and 3, which will add them together and print 13 to the screen. And there's your 13. And so you can just keep changing these numbers to do different calculations instead of rewriting code over and over and over again, which slows everything down over time once you get more and more code. So you try to limit the amount of code by using a function because of its reusability. So I'll show you something else. Instead of just returning these parameters this way, we could actually store variables in here that, these parameters become the variables inside. And we could say var a. And instead of writing var 3 different times, one off the root, we could separate it by commas and just a b. And then separate another comma and say z equals a plus b. So now we have 3 variables here, a, b, and z does the calculation of a and b. It adds them together. So now instead of that, so that it will actually return it back to the function, we have to return it. So we'll return z, because that's the calculation. And then when we call it, we'll call it with different, I already put different numbers in there, I guess, 10 and 80. File, saved, refresh it, 10 and 80 will add, print out 90. And there you go, you have 90 on the screen. So this is what's known as a function declaration. It's using the keyword function. The function's name is add. It has parentheses where you can pass in parameters. And I don't know how I did that. I'll take that back out. And then within the function body, this open and closing bracket here, everything in between is what's known as the function body, is where your code goes that's going to do something. And then we return the calculation, calling the variable z to the function. And then we call right here the add function down here, or invoke it, passing in our arguments to print the screen. So let's see, what else can we do? So you're not just limited, and you don't have to have, depending on what your function does, you don't have to have any parameters. Like we could take all this out and have no parameters and just say return 2 plus 5 to get 7. And I'll take this return out. And then we'll take these arguments out. So you can see that it still will run the function without parameters or arguments. Refresh the screen, and there you go, you have 7. So it depends on what your function is doing. A lot of functions don't have parameters. Sometimes the function parameters are going to be, the arguments are going to be objects that are actually passed in. But I'll talk to that in the more high-level classes that I give down the road. And let's see here. And then one other thing I wanted to cover is the functions you create and the function invocations. It's not highlighting right here. The function invocation and the function you create don't have to be within the same HTML page. You could put it in a separate script. So we'll cut this out, and then let's put the parameters back in. I'll put a, b, and we'll just say return a plus b, and then we'll pass in 10 and 5, so we'll add those out to be 15. But what we're gonna do is we're gonna cut this out, put an external JavaScript file outside of the HTML file. Right now we're in an HTML file which runs the JavaScript because we are running the JavaScript in between the script tag here. So the script tag knows it's what's called internal JavaScript, and the closing script tag here, we're running our JavaScript between those 2 tags. But if we want to run it into an external script, we can. And we can build all our functions, like right here. I have a script tag just above the closing head tag, the HTML head tag. It's best to put all your script tags. The code runs in it reads from top to bottom, so JavaScript likes to run first in the browser. So if I had put this above something, perhaps my CSS, which is this code right here in between the style tags might not run. JavaScript likes to be a hog. So I'm running after, and it's going to go in the order of execution. Also important is, say you have some JavaScript libraries you're using that are built by other people. You will put your library first, and then your script where you're going to build your, where you're going to run or invoke their methods or their functions below that, so it can read the library first, so those functions are created, and then it will read your code. So we'll go to this one. So right here I have an external sheet called, there's nothing in it right now, called javascript.js, and I have it right here. And I'm going to cut this and put this in it, so you can see the functions can be in a separate document. Print. And we'll save that. And we'll come back to our document. We'll save this. And we'll refresh the page, and it should print 15 with our, as we pass some new numbers now here, even though the function is not within this document. And there you go, you got 15. So your functions can be provided a layer of separation. You can, create all your functions or your library or API in JavaScript and put it in an external document, whatever it's going to be called, a lib, whatever. And then you can run all those methods or functions. If it's a function that's built in an object, it's known as a method of the object. If it's just a separate function or a function on its own, it's known as a function. And you can run them here or invoke them in this page, calling them to run the code over from here. Also, you could even invoke your functions in a separate JavaScript page too, but it would have to be below the page where all your functions are declared. Alright, we'll go over a few more things here. Let's see here. My next class is going to be pertaining to function expressions, which are different. And the difference is, let's write another function, multiply, real quick. And we'll pass in two parameters again, A and B. And we'll say return A times B. And we'll change the function name, so we'll invoke it, multiply. And it's going to multiply 10 and 5 to get 50 when we run it. But before we run it, I'm going to show you something interesting. So if we take this and we cut it here and we put it above the function we just created, cut, it will still run. So we're invoking it before the function is actually written, and this is what's known as hoisting. And with function declarations, it works just fine. So when we refresh the page, we'll print 50. And there you go, 50 to the screen. So with function expressions, that's not the case. And I'll explain a little bit in a minute with my best words. What's happening is JavaScript knows, it sees this function being invoked, and it looks for it to see where it is first, and it runs down here, and then it returns back up here to invoke it, the code. And that's what's known as hoisting, calling your functions or invoking your functions above the declaration will run just fine. However, if this was a function expression, meaning the function is stored in a variable, also known as a nameless function or anonymous function, because it doesn't really have a name, it's just a function stored in a variable, A and B, and we save it. So as you see, what I did is I still have the keyword, but it's not referencing a function because there's no name. It's just a function with no name being stored in this variable multiply. So when we run it, it will not run. This 50 will go away and there'll be nothing on the screen. And there you go. See, there's nothing on the screen. And the reason that is because this function is being stored in a variable. So this variable hasn't been rendered or created yet. So this function is looking for, this function invocation is looking for a function, but it can't find it because it's stored in this variable. So it doesn't run. Now if we cut it again and invoke the function underneath, and then hit save and rerun it, the 50 will come back to the screen. because as I said, code's read from top to bottom. So now this variable is storing this function is read before it gets to this function invocation, and it prints just fine. And you might be saying, well, why use function expression then if you can't hoist it and this and that? It's going to cause problems. Well, there's times where you're going to need it, and you know, I've read a lot of different stuff, and one of the things I read would say always use a function declaration, but that's not always the case, which means your function keyword and then the name of your function, which is best if you have a standalone function like this. But this doesn't work for, say, like you're creating a constructor function, which is going to construct instances of objects, which I'll get into my higher level classes later. But and those functions, those constructor functions, might either have methods, because a function is nothing but an object. So a function in a constructor function becomes a method, or on its prototype becomes a method, because a prototype is also an object. So it becomes a method of that function. But however, you know, when you're doing constructor functions, they have to be or your methods of your constructor functions, they have to be written in as function expressions. There's really, as far as I know, no other way to do it. At least I haven't seen it. And what it would be like if this was a constructor. Let me just show you real quick to make another object, person. And constructors are always capitalized, so you know it's a constructor. And we'll just pass a name, age. Oh, caps lock. And we're going to use a keyword called this, and this is a keyword just refers to whatever current object it's in. If it's not in a current object, it would come out here and refer to the object out here, which is the global object, being object of JavaScript. So this dot name, and we're going to equal it to name, and this act as parameters as well, because we have parameters in here, so it's going to reference this. This dot age equals age. And our arguments are going to, when we call this function, we're going to pass our arguments into the new object that we create, the instance of this object. And all objects you create based off this constructor will get the same properties, but their values will be different. So if we come down here and create a new object from it, variable, say person equals new. You have to use a new keyword to create a new object of the first constructor. And then we'll pass in a name here. We'll pass in devil dog for life, separated by comma, and then we'll pass in the age, 40. So then when we call this object, call it down here. So this object, person, I'm sorry, no, that's correct. So we'll call this object person, and then dot age, and it will print, and then we'll put it will print I'm sorry, take that out because it's a property of the object. File, save, it will print 40 to the screen, and we got 40, and that's what I said name. Dot name is known as dot notation for objects. If person is an object and it's referencing the name property now, which will print this argument right here, double dog for life. File, save, refresh, and there you go, double dog for life. So with that being said, there are methods that could either be built in here in the constructor or out here on the constructor's prototype, which is another object that every function can reference. You know, I'll get more into prototypes way down the road when I get into my higher level classes. Anyway, so if we had a method here, we have to use this to refer to the current object. Dot, and we'll call get info. And so we have to do it this way. We have to use an expression function. So a function with no name that's being stored in this variable right here, get info from the function, and we'll return this dot name plus this dot age. That's going to return my name and my age, and we'll put a string in between there. Plus concatenation is, so we'll say double dog for life is 40 when it prints a screen. Now, because we're going to call it down here, when we call the person object, it's a method of this object now, of this person object. So let's get info. So to invoke it, we have to invoke it with parentheses, just like any other function or method. And it doesn't take any parameters. So when we say it will print double dog is 40. Double dog for life is 40. So you see there, so that's a method. So this is one case where you have to use a function expression built in. And we could pass in parameters too. We could pass in whatever. like say we'll pass a parameter, we'll call it programming, and we'll call it that in here too. So we'll pass in a parameter. So dog for life is 40, and we'll pass another string plus, and the string likes, and then we'll pass in our parameter, which is programming. Or we'll just put code. No, we'll leave it programming plus programming plus programming. So now we have this new parameter. We're going to have to actually pass it as an argument to this getInfo. So to do that, we're going to what do we want? Dog for life loves JavaScript, or likes, and we'll put as an argument JavaScript. And I'm going to change that because, and so now we have this argument here. If I'm going to change this to likes to loves because I love JavaScript. And we'll refresh it, save. Then use dog for life is 40 and loves JavaScript. Oh, let's change that, it doesn't look right. And refresh again. And loves JavaScript. So you can see when you do need a function expression, and I'll cover those a little bit more in my next class. And I think that's about it on function declarations for now. If you like my videos, please subscribe below. Thank you.